Alright, we're going to be working on 6.2.3 exponential functions. I have the checkup problem as usual, and then I'm also have a page from the study guide. Again, the studies have all been provided to you with the answers in them. If you don't have that in your email, I sent that email beginning of last week, um, beginning of the first week of summer school. Please reach out to me, and I'll make sure you have that. If you ever don't have something, just ask, and we can get it to you. Um, Now, okay, so exponential functions, we will say exponential functions, we will say what they are. Exponential functions are in this form. F of x equals a times b to the x. These are called exponential functions because our variable, our x, is in the exponent. All right, so exponential function has a variable in the exponent. Now, a represents the initial value. All right, so a is your starting point, wherever you start at. And then b will either represent your growth factor or your decay factor. All right, growth factor or decay factor. Now, when is which? Exponential growth is whenever a is greater than 0 and b must be greater than 1. Exponential growth, b is greater than 1. Exponential decay, b is greater than 0 but less than 1. All right, so that's what we're going to be looking for. So going to question 1. Now, they want us to evaluate, but the first thing I want us to do is I want us to identify if this is going to be growth or decay. Why? If we know it's supposed to be a times bx, in this scenario, I'm going to say a is 1. Oh, that's an awful one, even for me. And b is 4. Well, that 4 is greater than 0, so this is growth. This is exponential growth. And now to evaluate, they want f of 3. Well, the 3 replaces the x, so I replace the x, and it's just 4 cubed, and I don't have a calculator in front of me, but 4 times 4 is 16. 16 times 4 is going to be 64, I think, right? So that's just a calculator plug-in at this point. Just plug that in, right? But going back to this was a couple units ago, right? Whatever goes in the parentheses goes in for the x. All right, now if I switch it over to question 2, my a is 1/8, and my b is 5. Well, that b is 5, so that's growth. And that's all that matters to me. Okay, now we got to find f of 2. So I know the 2 replaces the x, so that x becomes 2. And this is going to be 25/8. And that might, you can get a decimal answer, that's fine too. But, right, the key is if they want us to evaluate this stuff, this is easy. I just plug the 2 in for x. I just plug it into the variable and solve the equation, use a calculator if it needs to. Doesn't bother me. Now question 3, all right, my a value is 9. All right, so that's a, and my b value is 1/5. This is decay, right? This is our first decay one, right? It's less than 1 but greater than 0. That is decay. Excellent. Now I need to evaluate with a -2 in for x. Uh-oh. So I have a -2. All right, so I'm actually going to work this one all the way out. I'm going to put myself in a scenario where I have room to do it. All right, so I'll probably just cover it up later. All right, so I have 9 times 1/5 to the -2 power. All right, the first thing I want to do is I want to use my quotient rule. Well, my quotient rule is 1 to the -2 power and then 5 to the -2 power, right? I just basically quote unquote distribute. This is a wrong word, but I'm distributing that -2 to the numerator and the denominator. Distributing is the wrong word. Don't yell at me. All right, so now I have negative exponents. Well, how do I get rid of negative exponents? Well, I switch their location. All right, so now I have a 5 with a +2 on top and a 1 with a +2 on bottom. So this is now 9 times 25. So I think it's going to be 225 after I solve it. Cool. All right, so I used my quotient law and I used my my negative exponents law. And I just plugged into the calculator. I never get my answer. All right, so you got to go back to those exponent laws that we covered in the first section of this unit. All right, so you can't just forget them. Kind of keep them handy. We'll use them throughout. All right, now going to 4. 4, I'm just going to say is a growth function, right? Because b is 2, and then I have to find f of 7. Well, that just means I plug 7 in for x. And you guys can plug it into your calculator. We don't need to go too far. All right. Now this is what is x if f of x is 64 in the function below? All right. Well, so we're going to have 64 equals 4 to the x. Well, what you should do is test. All right, just going to be a guess and check here. 4 to the first power is 4. 4 squared is 16. 4 cubed is 64. Oop, there it is. So x equals 3. You want x equal to 3, and that will give you 64 in this scenario. So this is kind of just kind of a guess and check. Not the best question they could ask. All right. Population of a town can be modeled by f of x equals 17,200 times 1.1x. So 1.1, I see the base is a 1.1. That means it's growth. All right. So they want us to identify. I'm going to change my colors. They want us to identify the initial value, right? If we go back and remember, my initial value is always that a value, right? Initial value is a value. So I know my a is equal to 17,200. They want to know if is it increasing or decreasing. Well, how do we know? Right? Well, if it's growth or decay. Growth increases, decay decreases. Well, this is a 1.1, it's greater than 1, so this is an increase. So we have an increase here, and then the next question is, what is the growth or decay factor? Okay, now the growth factor, because we know it's going to be an increase, so our growth factor is that 1.1 is my base. All right. How does the population change each year? Well, each year it's that growth factor is 1.1, so it increases 1.1 times. So it goes up 1.1 times each year. Or there's a 10% increase, however you want to look at it. It's always 1.1 times the previous year. And that's directly from the 1.1. So we have to do the same thing. What's my initial value? Well, initial value is going to be that first number, so 19,820. Cool. Uh-oh, I now am less than 1, so this is now decreasing, and we have decay. And the decay factor is the 0.98. Now, how does the population change you? Now, this is a little bit different. What I want you to think of this is that this is actually 2% smaller. All right, so we normally would start at 1, which is 100. And now we have 98 each time. So similar to what we did up top is 1.1 times the previous year. It would be 0.98 times the previous year, right? So it's getting smaller. So we will still multiply the same thing. I mentioned the 10% in the first problem. Just know that what's missing is 2%. So we had 100. We're only taking 98. That means we are decreasing. We're getting smaller by 2% every year. If I did the same thing up here, I have 100, and then I have 110. I'm going to ignore the negative piece of this. And the difference between 100 and 110, which would be the 1.1, right? If I just move the decimal over, the 1.1 is 110, is a difference of 10%. And I know this is going to be an increase of 10%. So whatever is changed from 100, so 1.1 is a 0.1, is a 10% increase. 0.98 is a 2% decrease. Whatever is missing from 100 will be what I'm actually changing each year. Okay, so use a general form of an exponential function to write a specific function given an initial value of 61. Initial value that tells me is A. Growth factor is B. So the formula is just going to be 61 times 3.5x. And I guess we should add the function notation at the front. That's all they want, right? The initial value is A. The growth factor is B. We just plug it right in. There's only two variables. Perfect. Now it's the same thing, right? They give us an initial value, that's A. They give us the decay factor, that's still B. That's all it is. All right, now the last one. There we go. There's I knew I had interest stuff. All right, how much would $400 invested at 5% interest compounded annually be worth after 6 years, right? Well, we have to have our compound interest formula. We have A of t equals P1 plus I to the t power. Now, what do all these values mean? Well, A of t is just however much money's in the account, right? So that's what we're solving for. It's just the amount. Well, P is your original amount. It's your principal. Well, it's how much you put in the account. Well, you're investing $400. That's your P. So $400 is your P. The 1 is just a number. It doesn't change. And then the I. Well, the I is the interest rate, and it's written as a decimal. So we have 5%. That's the same thing as 0.05. That became my interest rate. And then T is the number of years. Well, 6 years. Boom. There you go. You plug that 6 right in, and then I just plug this into a calculator and I solve. So again, this formula is right here in your study guide. Make sure you have it, and it'll help you out.